Okay, so for those of you who forgot, we are measuring the rate based on the change in concentration of the thiosulfate divided by 6 divided by time. The 6 comes from the stoichiometric ratio from reaction number 1 and reaction number 2 on the lab. The change in concentration of thiocyanate we determined from how much thiocyanate we added. Here's the molarity. However, we diluted it by adding 5.5 milliliters of other stuff. So the total volume is 6 milliliters. So we diluted that concentration. Therefore, the actual concentration is this, dividing it by 6, dividing it by your time. So if you just take that number, divided by 6, divided by your time, you get your rates. And Igor was so nicely did this for us and gave us the calculations. Thank you, Igor. Or is it Igor? I forgot. So we got the rates. We have the times. Now we got to calculate the concentrations. Yay! And it's going to be repetitive math just like with the rates. So we go to our, well, you guys are the advanced class, so you should be able to know how to calculate a dilution. Let's start with iodine. For experiment number 1, how much iodine did we add? 1 mil at 0.010 molar, right? So, time for some stoichiometric fun. So, we've got 1 milliliter. Convert it to liters. The molarity was in 1 liter, 0.010 moles of, what was it? Iodine, right? But then what was the total volume after dilution? 6 milliliters, right? So we have to divide it by 6 milliliters, but molarity has to be in liters, so we're going to divide by that. If we look at what cancels, that cancels, that cancels, that cancels, that cancels, we're left with moles per liter. Right, so that comes out to be 0.00167 molar. Actually, I'm kind of missing some sig figs there, sorry. So there's the molarity of the iodine for experiment number Yada for our Polish friends right now.
I think it was only 2 sig figs.
I know.
Where's adding them?
We really shouldn't. It really actually had 2 sig figs, but there we go. I just hate 2 sig figs because it's not as accurate as 3. So that's the concentration of the iodide for reaction 1. We have to do the same thing for the bromate. So, what was the amount of bromate we added for reaction 1? 1 mil, 0.040 molar. So now we do the concentration of bromate, 1 mil. Experiment 1, this is for the bromate. So 1 mil converted to liters. In 1 liter, there's 0.040 moles of bromate. And what did we dilute it by? That many liters. So yes, Felipe, there should be 2 sig figs. So it comes out to be 0.0067 molar of bromate. See how we did that, Pashemek?
Yeah.
Okay. So now we got that one down. So now I got to calculate the concentration of the acid. All right, Gunter, go back to our experiment 1. H plus. How much did we have? 1 mil, 0.1 molar. So 1 mil, (1,000 milliliters). Converted to liters. Then the molarity was that. And once again, divide by 0.0600 liters. And I got 0.016 or 0.017 is what I got. Oui?
Oui.
Yeah.
Si.
Comprends?
Si.
Très bien.
Ja.
Wunderbar. Now what you get to do is to calculate the initial concentrations for the rest of these. Okay? So this is my recommendation because it's not changing from lab group to lab group. How about we split this up and then share the data, but we're going to build some redundancy in it so in case somebody messes up, we don't have problems. We have 2, 4, 6, 7 of these. So you guys do 2 and 3. You guys do 4 and 5. Let's see. 5. You do 6 and 7. You guys do 7 and 8. Okay? That way there's at least one other lab group to check off to make sure that someone didn't mess up the calculations. Okay? So go ahead, just calculate them all out, and then we'll share the data.
Do we need to write down all of our? You guys are doing 4 times.
I'm doing 2 on Tuesday.
Do you have to show for all of them or just?